Hello AP Physics 1 students. It's time for us to start reviewing for the AP 1 exam. We're going to start with mechanics, and we're going to start with how do we begin. All right? So here we start. All right, when you first see a physics problem, a lot of you begin with, I'm really confused. You don't know where to start. In fact, if we had a live feed into your brain, it would look something like this. You don't know what the heck it is. We didn't do anything like this in class. What the heck am I looking for? I don't know where to begin. I don't even know what the question is asking. My teacher didn't teach me any of this. It's not my fault. I'm so dumb and I hate physics. Cry, cry, cry. All right, so I don't want you to feel that way. We have learned a lot. You've learned a lot. So we just need to organize it. You just need a little practice. So here we go. Anytime you're looking at a mechanics problem, mechanics is like the physics of physical things, all right? So not circuits, not charges, not waves, but like physical objects and what they're doing. Always think in terms of these big four ideas. Motion in kinematics. What's the object doing? Where is it moving? How's it moving? Is it accelerating or not? Is it any special kind of motion? Like, is it going in circles? Is it changing direction? Is it oscillating? Is it rotating? Okay, so pay close attention to its motion. Second thing is look at the forces that are acting on it. So this is the idea of dynamics or Newton's laws. Do all the forces cancel out? Which forces are there? Is the object accelerating? Because there's more forces in one direction than another. Okay, so keep an eye out for the forces. Next, and this is particularly useful when we have multiple objects that are interacting, the idea of impulse and momentum and conservation of momentum. And then our last big idea is probably your go-to. If you can solve it with energy and work, it's almost always the easiest way to solve a problem. So look at the energy count of the object. How much energy does it have? What kinds of energy does it have? Is the energy being conserved? All right? So, like I always tell my students, put on your motion glasses, and what do you see? Put on your forces glasses. What forces do you see? Put on your momentum glasses. Is momentum conserved? What's going on with momentum? And then put on your energy glasses, and what do you see as far as energy goes? Is there energy being added by work or taken away with negative work, or is the energy staying the same, and what kinds of energy are there? All right? So, a couple of things about these. These four big ideas fall into two different math groups, and it's very important that you know the difference between the two. Motion, forces, and impulse and momentum, these are all vector math ideas. You're going to have to use trig. Think of vectors as verbs. Vectors represent an action in a direction. So like a displacement, you're moving in a certain direction. A velocity, negative velocity means you're moving in the negative direction. An acceleration or a force up or a force down, say from gravity. So vectors are represented by arrows, and these arrows have x and y components. And the x and y components are independent from each other. So the x, what goes on in the x direction, will be separate from what goes on in the y direction. And then for vectors, this is a big idea. Plus and minus means, is it going up, down, left, or right? So the plus and minus means direction. So in the y direction, plus might mean up. Or in the x direction, plus might mean to the right and negative to the left. Okay? So we're going to have to use geometry and trig to separate our vectors into components. This is true for motion, forces, and impulse and momentum. However, energy, work and energy, conservation of energy, this is a scalar math idea. Energy is a scalar. It has no direction. It's just a thing. It's a quantity. So it's like, how much do you have? It's like money. How much money do you have? Is the money going up? Is the money going down? All right? So think of scalars as a noun. They represent a thing. Energy is just a number telling you how much that system that you defined has. Okay, it's just a number. Mechanical energy, which is what we'll be talking about, depends only on how fast the object is going, kinetic energy, or the relative positions of the objects in the system. So, like, how far away is the object from the Earth? The farther away they are, the more potential, gravitational potential energy they have. Or, like for a spring, if you include a spring in the system, then how is that spring arranged? Is it stretched? Is it compressed? Or is it in its normal equilibrium position? That will depend on how much potential energy it has. So plus and minus in scalar math has a totally different meaning. It is not direction. Plus and minus for, say, like work means adding or subtracting the energy from the system. Okay, so like plus work would mean getting more energy. Negative work would mean energy's leaving the system. All right? And that's it. That's the big four ideas.